Good morning, everyone. Today we're going to take a look at lesson 2.2, which it's kind of an introduction to linear functions. So we talked about functions on Tuesday after our test, and now we're going to take a look at specifically linear functions. So the homework assignment here, again, that can be noted at the top. So we're looking at page 71, 1 through 4, 12 through 15, and 35 through 38. So our objectives today, guys, we're just trying to get familiar with linear equations, talk about standard form a little bit, identifying linear equations. We should be able to do that at the end of the lesson, identify what is a linear equation, and then we'll look at standard form a little bit, and then graphing out of standard form. So first here, let's talk about linear relations and functions. The points on the graph above lie along a straight line. Relations have straight line graphs are called linear relations. Okay, relations that are not linear are called nonlinear. So we have linear and nonlinear. So we're going to look at some equations down here. They've got 4 examples of linear equations. Okay, these should all look somewhat familiar. So this first one, this is what we call standard form. Standard form, and that should be familiar there. X equals 10. Well, yeah, that's a straight line. That's actually a vertical line. Okay, you go out to 10 on the x-axis and you draw a vertical line. These next two are in slope-intercept form. So both of these next two here are in slope-intercept, and that's y equals mx plus b. So, so these ones are nonlinear, and let's kind of discuss why these 4 over here, why do they fall in the nonlinear equation category here? Well, this first one, it has an exponent other than 1. This one has an exponent of 2. So here we see that it's 6y squared. Okay, if we see squareds and square roots, that's going to make it nonlinear. It's going to be a curve. Okay, it's kind of the same reasoning here on this next example. You see a square root. Okay, linear functions do not have square roots. Square root of 2 can't exist. All right. Third example, x and y are being multiplied. You guys can see that here. We've got this term here, xy, that means x times y. These are being multiplied. They're not being added like you would see in a linear equation. The last one, you can't have any variable. So no variable n, and I'm going to abbreviate here, but this is denominator. No variables in the denominator. So this one has 1 divided by x. X is in the denominator of this fraction. So you can have fractions, okay? These 2 examples over here, both of these examples, they have fractions. You're able to have fractions. You can't have variables in the denominator. Alright? So let's talk specifically then about functions. So linear function is a function with ordered pairs, x and y ordered pairs, okay, that satisfy a linear equation. Any linear function can be written in the form f of x equals mx plus b, where m and b are real numbers. So let's take a look here. State whether each function is a linear function, right? Yes or no. I guess also, yes, we should get familiar with the idea that we're using function notation a lot here in Algebra 2. Instead of y equals, a lot of these are going to be using function notation where we say f of x or g of x or h of x, okay? So we should get familiar and comfortable with that, using f of x instead of y. Alright, so this first one, could this be written in y equal, or f of x equals mx plus b? Can it be written in slope-intercept form? Well, yeah, this one could be. Well, what if we just wrote it like, if we switch these places, what if we wrote negative 3/4 x, and that's a plus 8? Well, yeah, okay, so this is linear, so yes. This first example. Example B here, well, this looks pretty similar to the non-example we had up there, the non-linear. Okay, so this one would be a no. Well, why? We need some sort of explanation here. We have x in, and again I'll abbreviate, we have x in the denominator. Alright. Example C, you guys should be able to see that that is similar to one of the non-examples. Okay. If we're looking up here towards the top, we've got this example where x and y are being multiplied together. Well, in example C, this term right here, x and y are being multiplied together. So this is not linear. This is a no. Why? Well, x and y are being multiplied. Okay. These next two examples, I'd like you guys to go ahead and pause and try these next two. So on 1a, we say no. We should have said no. Okay. This has x in the denominator. Okay. So no variables in denominators. 1b might have been a little tricky, but I tried to make it pretty clear up at the top here. We can have fractions so long as x is not part of the fraction. So this is already in slope-intercept form. So yes, this is a linear function. Okay. So your first few problems there on the homework are going to be all pretty similar to these, where you've just got to be able to say, well, are these functions, are they linear functions, yes or no? Okay. So let's continue. Let's talk a little bit here about standard form. A linear equation can be written in standard form, ax plus by equals c, where a, b, and c are integers with a GCF of 1. So we've got examples, this example here, 3x plus 5y equals 12. Okay, a, b, and c are just integers, so that works. All right, next, guys, since 2 points can determine a line, okay, one way to graph, and this is an uncommon way to graph. You guys probably didn't do this very often in Algebra 1. You might have done it a couple times, but probably not very often. But this is a skill that we use a lot more, not necessarily on linear functions, we will today, but we use it on other types of functions we'll see throughout Algebra 2. So it's good to see it with a linear function, one we're pretty familiar with. Okay. But it's using the intercepts, the x-intercept and the y-intercept, okay? If we can find those 2 points, then we can just graph the line. We can draw the straight line through those 2 points, and we're good to go, okay? So, well, what is the y-intercept? The y-intercept is where a graph crosses the y-axis. So, to find the y-intercept, we are going to substitute x equals 0. That's when something crosses the y-axis, is when x is 0. Okay, to find the x-intercept, and I made a note here in the problem of this as well. To find the x-intercept, well, we're going to substitute a value. Well, let's think just for a second. The x-intercept's where it crosses the x-axis. So what would the y value be? What am I going to substitute for y? Well, when something crosses the x-axis, y is equal to 0. So we're going to substitute y equals 0. Okay. And when I say substitute, what are we substituting in? We're substituting into the function we're graphing here. So to graph using x and y intercept, do these 2 steps. Well, 3 steps really, because we got to plot points too. So first one, find the x-intercept, which means again substitute y equals 0. So looking at 3x minus 4y equals 8, substitute 0 for y. So this is 3x minus 4 times 0 equals 8. 4 times 0, guys. It's kind of nice to use intercepts because 4 times 0 is just 0. This cancels out. It's just 3x minus 0, which is 3x equals 8. Divide both sides by 3, and we get that x equals 8 over 3. And that is when y equals 0. So the ordered pair this produces is 8 thirds. comma 0. That's a point we can plot on the graph. And so let's do that. Let's plot the point 8/3, 0. So 8/3 is 2 2/3, right? So 2 2/3 on the x direction. So that's between 2 and 3 on the x-axis. And then so we're going to find the y-intercept, which is substituting x equals 0. So again, we're using the same equation here. This one works out a little more nicely because when we plug in 0 for x, and it cancels away, 3 times 0 is 0, we're just left with negative 4y equals 8. And I say this one's nicer because 8 divided by negative 4, well, we're not left with a fraction. That's actually just negative 2. And so y equals negative 2, and that's again when we substituted x is 0. So what's the ordered pair here for the y-intercept? The ordered pair, the point is 0, comma negative 2. So plot both points and connect them. So 0, negative 2 is right here. And then we're just going to connect these, and we have graph the line. And so again, I know this isn't a common way that we've graphed linear functions previously, okay, using intercepts, but it's effective. We've plotted 2 points, so we have an accurate line, and this idea of intercepts is something that's going to kind of keep coming up as we go through the semester, and then even into second semester Algebra 2. This is applicable. So the last few problems, so this is it. We're done for the notes. The first 4 problems there are going to be saying whether something is a linear function, and then these last 2 sets, these are graphing using the intercept. So again, I want to see you guys use the intercept, substituting in those zeros. Okay, we got to build up that skill. So please practice that on those last couple of sets of problems there. Alright, well, this wraps it up. You guys have got the assignment there. You guys go ahead and get started on that. That'll be due tomorrow.